Suppose we want to factor something like x to the fourth minus 13x squared plus 36. This expression isn't a quadratic trinomial since we have this x to the fourth term, but we'll notice that it has 3 terms and all the exponents are even, or a multiple of 2. The x to the fourth term and the x squared term both have even exponents of 4 and 2, and the constant term of 36 technically is 36 times x to the 0, which is also an even exponent. So this means we can rewrite the expression as x squared, all squared, minus 13 times x squared plus 36. This is useful because we have rewritten the expression in terms of x squared, so we can convert this into a quadratic trinomial using a change of variables. What this means is we let u equal x squared and rewrite this expression in terms of u instead of x. So if u equals x squared, then the expression is equal to u squared minus 13u plus 36. Notice how we substituted for u whenever there was an x squared in the expression. So now this expression is a quadratic trinomial in terms of u, and we can use the usual techniques for factoring trinomials. So in order to factor the trinomial, u squared minus 13u plus 36, we need to find two numbers that add to negative 13, which is the coefficient in the middle term, and multiply to 36, which is the constant term. So the two numbers with these properties are negative 4 and negative 9, because negative 4 plus negative 9 is equal to negative 13, and negative 4 times negative 9 is equal to 36, and that's what we want. So this means we can factor the expression as u minus 4 times u minus 9. So we're not done yet because we still need to substitute back the x squared for the u, so we can find the factored expression in terms of x, which is the variable in the original expression. So u minus 4 times u minus 9 becomes x squared minus 4 times x squared minus 9, because whenever there's a u, we just replace that with x squared. So we can actually factor this further, because x squared minus 4 is a difference of two squares, a squared minus b squared, where a equals x and b equals 2, since 4 is equal to 2 squared. You may recall that a squared minus b squared is equal to a plus b times a minus b. So x squared minus 4 can be factored as x plus 2 times x minus 2. X squared minus 9 is also a difference of two squares, where a equals x and b equals 3, since 9 is equal to 3 squared, so it can be factored as x plus 3 times x minus 3, which would be the expression a plus b times a minus b with the given values. So now this expression is fully factored, and this is our final answer. Alright, so here's another example. So we can see that this is a fourth degree polynomial with only even exponent terms. So we have the x to the fourth term, x squared term, and the constant term. So this means we can rewrite the expression as 3 times x squared, all squared, minus 22 times x squared, minus 45. So this means we can do the substitution u equals x squared, because if we let u equals x squared, then this expression is just equal to 3u squared minus 22u minus 45 if we substitute for u whenever we see an x squared in the expression. So now this expression is just a quadratic trinomial in terms of u. To factor this trinomial, the first thing we need to do is to multiply the coefficients of the first and last terms in the expression, which are 3 and negative 45. 3 times negative 45 is equal to negative 135. And now what we need to do is to find two numbers that multiply to negative 135 and add to the coefficient of the middle term, negative 22. The two numbers with this property are negative 27 and 5, because negative 27 plus 5 is equal to negative 22, and negative 27 times 5 is equal to negative 135. So now we just need to take the two numbers, negative 27 and 5, and split the middle term with these two numbers as coefficients. So this means we need to rewrite the negative 22u term as negative 27u plus 5u, which is equivalent since negative 27 plus 5 is equal to negative 22. So this expression just becomes 3u squared minus 27u plus 5u minus 45. To factor this, we can use factoring by grouping. We'll put the first two terms in a group, and the last two terms in another group. So in the first group, 3u squared and minus 27u both have a 3u in common, so we'll factor out a 3u from both terms. If we factor out a 3u from 3u squared, we're left with a u, and if we factor out a 3u from negative 27u, we're left with minus 9. So in the second group, 5u and minus 45 both have a 5 in common, so we'll factor out a 5 from both terms. If we factor out a 5 from 5u, we're just left with u. And if we do the same with the minus 45, we're just left with a minus 9. So now we can clearly see that both terms have this u minus 9 term in common, so we'll factor out the u minus 9 from both terms. So if we factor out a u minus 9 from the first term, we're just left with 3u, and if we do that with the second term, we're left with the plus 5. So this expression is just factored as u minus 9 times 3u plus 5. So now we need to substitute the x squared back in for the u. So the expression becomes x squared minus 9 times 3x squared plus 5, since whenever there's a u, we need to replace that with an x squared. We can actually factor this further because x squared minus 9 is a difference of two squares, since we can think of x squared minus 9 as x squared minus 3 squared. So we can factor this as x plus 3 times x minus 3. But the 3x squared plus 5 can't be factored any further, since it's not in the form of a difference of two squares. So the 3x squared plus 5 just stays the same. So this expression can be factored fully as x plus 3 times x minus 3 times 3x squared plus 5. And this is our final answer. Alright, so here's a slightly more interesting example. In the first part of the expression, we can see x squared plus 4x all squared. So this suggests we might want to substitute with u equals x squared plus 4x. But we don't see x squared plus 4x anywhere else in the expression. But you may notice that the ratio of the coefficients of the x squared and x terms is 1 to 4, and that's the same as the ratio of the coefficients of the x squared and x terms in 9x squared plus 36, which is also 1 to 4. So this means we can factor out a 9 from the 9x squared plus 6x and rewrite it as 9 times parentheses x squared plus 4x, and the plus 20 stays the same. When we do that, you'll see that we now have another x squared plus 4x in brackets. So this means we can substitute u equals x squared plus 4x. So if u is equal to x squared plus 4x, then this expression is just equal to u squared plus 9u plus 20, because we substitute u whenever we see an x squared plus 4x. So now we need to factor this quadratic trinomial in terms of u, and to do that, we need to find two numbers that multiply to 20 and add to the coefficient of the middle term of 9. And the two numbers we need are 4 and 5, because 4 plus 5 is equal to 9, and 4 times 5 is equal to 20. So we can factor this expression as u plus 4 times u plus 5. If we substitute the x squared plus 4x back for u, the expression becomes x squared plus 4x plus 4 times x squared plus 4x plus 5. So we can actually factor this further because x squared plus 4x plus 4 is a perfect square, because if we let a equals x and b equals 2, then a squared plus 2ab plus b squared is just equal to x squared plus 4x plus 4. So we can rewrite this as x plus 2 all squared, and x squared plus 4x plus 5 can't be factored any further, because if we look at the constant term 5, there are no two numbers that multiply to 5 and add to the 4, which is the coefficient of the middle term. So this part stays the same. So x squared plus 4x plus 5. So this means the factored expression is just x plus 2 squared times x squared plus 4x plus 5. So here's another one. How do we factor 12 times x squared plus 2x plus 2, all squared, plus 7 times x squared plus 2x plus 2, and then plus 1. So we see a lot of x squared plus 2x plus 2 terms, so we can do a substitution and let u equal x squared plus 2x plus 2. So if we substitute for u whenever we see an x squared plus 2x plus 2, this expression becomes 12u squared plus 7u plus 1, and now this is just a quadratic trinomial, which we can easily factor. To factor this, we need to multiply the coefficients from the first and last terms. So 12 times 1 is equal to 12. So we need to find two numbers that multiply to this 12 and add to the coefficient in the middle term, which is 7. And the two numbers that have this property are 3 and 4, because 3 plus 4 is equal to 7, and 3 times 4 is equal to 12. So this means we need to split the middle term into 3u plus 4u, so this expression is just equal to 12u squared plus 3u plus 4u plus 1, since 3u plus 4u is just equivalent to the 7u. To do the factoring by grouping, we need to put the first two terms in a group and the last two terms in another group. So in the first group, 12u squared and 3u both have a 3u in common, so we'll factor a 3u out of both terms. If we factor out a 3u from 12u squared, we're left with 4u, and if we do the same with 3u, we're left with 1. So in the second group, 4u plus 1 can stay the same, since we can't factor anything out of both terms, so we'll just write a plus parentheses 4u plus 1. So now we can think of 4u plus 1 as 1 times 4u plus 1, so then we can factor out a 4u plus 1 from both terms, and then this just becomes parentheses 4u plus 1 times 3u plus 1. So now we need to substitute x squared plus 2x plus 2 back for u. So if we rewrite the expression and substitute x squared plus 2x plus 2 whenever there's a u, this expression becomes 4 times x squared plus 2x plus 2 plus 1, all multiplied by 3 times x squared plus 2x plus 2 and plus 1. So if we simplify a few terms, this expression becomes 4x squared plus 8x plus 8 plus 1 times 3x squared plus 6x plus 6 plus 1. This simplifies further to 4x squared plus 8x plus 9 times 3x squared plus 6x plus 7. We can't factor this any further because both trinomials in the product can't be factored. So if we look at the first trinomial, 4x squared plus 8x plus 9, and multiply the coefficients of the first and last terms, 4 times 9 is equal to 36, but there are no two numbers that multiply to 36 and add to the middle coefficient of 8. For the second trinomial, this is also the case because 3 times 7 is equal to 21, and there are no two numbers that multiply to 21 and add to the middle coefficient of 6. So we can't factor this any further, and the original expression just factors to 4x squared plus 8x plus 9 times 3x squared plus 6x plus 7.